All right, so we're going to take a look at vectors again today. So we need to find the distance from A to B, the midpoint, and the position vector. So let's see, well, what is our vector AB? Let's start with that. So negative 1 to 1, that would be 2. 2 to 0, negative 2. 4 to negative 1, negative 5. So that distance, we extend the Pythagorean theorem, 2 squared plus negative 2 squared plus 5 squared. So 4 plus 4 is 8, plus 25 is 33. So we have the square root of 33. And then we have the midpoint. So our midpoint, we add our x's, divide by 2 for our x coordinate. We add our y's, divide by 2, and we add our z's, and divide by 2. So negative 1 plus 1 is 0 over 2 is 0. 2 over 2 is 1. That would be 3 over 2. So we have our midpoint there. Now the next thing we're going to do is we're going to look at something called the dot product and the scalar product. And this is if you're given vectors, maybe it's A1 and A2, and B1 and B2. The way you multiply those together is you multiply the x values and add them to the product of the y values. So if here are two vectors, we need to find the dot product. We're going to do 2 times 1 plus 3 times 4. So we have 2 plus 12, so our dot product is 14. Now the interesting thing about this dot product, if it equals 0, the vectors are perpendicular. So we need on this one, we have to find t such that a and b are perpendicular. Well, that means the dot product has to equal 0. So negative 1 times 2 plus 5 times t has to equal 0. So we have negative 2 plus 5t equals 0. Well, if we solve for t, add 2 and divide by 5, t is 2/5. So we have to decide whether these are parallel, perpendicular, or neither. So perpendicular, that's our dot product. If they're parallel, that means they're scalar multiples of each other. And you'll notice it's a little confusing because this is the scalar product. I usually just refer to it as a dot product. But scalar multiple is just when you're multiplying it by something. For example, this one, 6 times 2, it's divided by 3. So that's times 1/3. Well, do we get the same thing here? Is that times 1/3? Well, no. So it's not parallel. So let's check the dot product. 6 times 2 plus 4 times negative 3. 12 minus 12, well, that's 0. So these are perpendicular. Well, this next one, 9 to 3, we'll divide by 3, so that's like multiplying by 1/3. Divide by 3, so times 1/3. So these are parallel. And let's see this one, this would be times 0, so it's not that. So the dot product, 1 times 0 plus 3 times 5. Well, that's 15, so it's not perpendicular, so it would be neither. Because to be perpendicular, the dot product has to be 0. So we're going to see if this is a right triangle, and we're going to use the dot product. So we got to figure out some vectors here. We have 2, 1. Well, that's A. 2, 3, 4, 5, 6. Negative 1, so that's B. And C. 1, 2, 3, 4, 5. 1, 2, 3. So to use the dot product, oops, we don't know if that's right or not. It looks like it is. We have to make these vectors. So A to B. Let's see here. 2 to 6 is 4. But do you know what we're going to do? We better look at what, oops, that totally went away. Let's see if we can undo that. Edit, undo. So let's go. It's looking like this is a right triangle. So let's see. What is our vector from B? Oh my goodness. I am so sorry, you guys. What is our vector from B to A? So B to A, 6 to 2. So our vector is going down 4, -1 to 1, and up 2. And then let's check this one here, B to C. All right, B to C, 6 to 5, so it's going down 1. -1 to -3 is going down 2. So let's check that dot product. -4 times -1 plus 2 times -2. Well, this is 4 minus 4, which is 0. So yes, it is a right triangle there. All right, this next one, we're asked to find the dot product. So we're given two vectors and the angle between them. So we need to find those components. We have that magnitude, but what are the components? So let's just draw this. We know one, let's just say it's going this way. It might not be, but you know, that's √7. The angle between them, this would be 5, is 110. Well, we need those x, y components here. So this one going straight is pretty easy. We set that one up. That would be √7 and 0. But what about this one? Let's make it into a right triangle. X, y. Well, what would be inside here would be 70. And we could use some trig functions here to find it. Opposite over hypotenuse, our sine. So our sine of 70 equals y over 5. Now how about x? That would be cosine. So our cosine of 70, is adjacent over hypotenuse. Well, let's see. So y equals 5 times the sine of 70, and x equals 5 times the cosine of 70. All right, so 5 times cosine of 70, 5 times sine of 70, 4.7 and 1.7. So 4.7 and 1.7. And since this is going backwards, I'll make it a negative here. So we have -1.7 and 4.7. Those are our component forms there. So if we're to find the dot product, √7 times -1.7, 0 times 4.7. So let's see. Whoops, did not mean to do that. I'm having a little bit of trouble here today, guys. Sorry about that. Let's see if we can end this. There we go. Now can I get to that and just go back? There we go. So I wanted to go to the calculator. So √7 times negative times -1.7, -4.49. And that is our dot product there. So let's see, what are we going to look at next? We have to find the angle between these two vectors. So let's see here, 3, 2. So let's say we were going to go over 3, 1, 2, 3, and down 2. So here's this vector here. And then our other one, we're going to over 1 and up 7. Well, let's see, what are the lengths between these vectors? Well, let's see, 3 squared, or I should say the magnitude, so 9, 13, so this is the square root of 13, where this one is 7 squared plus 1 squared, 49 plus 1, so the square root of 50. And then what is the distance between these? Well, to A to B, you're going down 2, or over 2, backwards 2. So to get from these two, we go backwards 2 and up 9. So this one would be -2 squared plus 9 squared, 81, 82, 83, 85. And now what we have to do here is we're going to have to find this angle. So we want to find this angle. And we're going to go back to something we did 2 chapters ago, the law of cosines. So let's see if we can set that up here, our law of cosines. Well, we want to find this angle, so we're going to start with the square root of 85 squared, and then it's the other side squared, 50 squared, plus the square root of 13 squared, minus 2 square root of 50 square root of 13 times the cosine of theta. Well, this is just 85 equals 50 plus 13 minus 2 root 50 root 13, the cosine of theta. And this is where we combine those together. So 85 equals 63 minus 2 root 50 root 13 cosine of theta. Subtract 63. So we have 22 equals negative 2 root 50 root 13 cosine of theta. Divide by negative 2. So negative 11 equals root 50 root 13. If we divide by root 50 and root 13, sorry about that. Let's see, divide by root 50 and root 13. Negative 11 divided by root 50, the square root of 13. All right, and then we have to do that inverse cosine because we're finding our angle. So we end up with our angle being 115 degrees. Because again, we always do that inverse to find our angle. So the next thing we're asked to do is find the measure of ABC. So let's see here. If we were to graph this to negative 1, here's A. 1, 2, 3. So 3, 4. Here's B. Negative 1, 1, 2, 3. Here's C. So we want to find this angle right here. So once again, we have to find, what are these vectors here? So let's see, B to C. So that would be negative 4. 4 to 3 is down 1. So B to C is negative 4, negative 1. So if we square those, negative 4 squared plus negative 1 squared. So this is the square root of 17. And let's see here, what would B to A be? B to A, 3 to 2, so that's going down 1. 4 to negative 1, down 5. So negative 1 and negative 5. Negative 1 squared plus negative 5 squared. This is a mess, I apologize. So this is root 26. And then the last one, what is A to C? So A to C. All right, 2 to negative 1. So that's 3. Maybe I'll actually write this out. 3. And that's down 3. And then negative 1 to 3 is up 4. So negative 3 squared plus 4 squared. 9 plus 16. All right, well that would be 25. So this is 5. So now we can set up that law of cosines again. 5 squared equals root 17 squared plus root 26 squared, 2 root 17 times root 26 times the cosine of theta, and then you would solve it again.